Hello and welcome back to Precalculus1 Exam 2 overview and review, and that's it. So we said that Exam 2 is on Chapter 2 plus Chapter 2, right? Just Chapter 2. Why is this not working? Just Chapter 2. Now, the key for Chapter 2 is, as you know, factoring and looking for those roots and multiplicity and graphing and so on. So we know that the 2.1 is complex. We just have calculations. No graphing, no. That's it. 2.2, all, which in entire section, that's quadratic. And you know that you look at ax squared plus bx plus c, or you look at it as a function y equals a x minus h squared plus k. We have all of the concepts of what is orientation. What's orientation? Go opens up or down. And then vertex, right, which is min or a max. You need that for your problems, right? You know how to graph it. And I think that's it for, and maybe you want to know the quadratic formula, right? So you can find the roots. 2.3, we talked about graphing polynomials. Well, so graphing polynomials where you talk about the end behavior, roots, multiplicities, leading term test, no intermediate value theorem. 2.4, division of polynomials plus synthetic division plus factor theorem plus, there's one more thing there, remainder theorem. There we go. 2.5, we have again graphing polynomials. But this time we have spicier examples. We do the PRs, right? Combined with synthetic division. And Descartes' rule of signs. I think that's it. Yep, that's it. And 2.6. Rational functions. We're talking about vertical asymptotes. Va. Horizontal asymptotes. Ha. Slant asymptotes. Sa. And then we have So 3 types of vertical asymptote with their rules, right? You need to know the rules for all of those. And then we have the graphing. Rational functions, which involves what? Domain, x and y intercepts, all asymptotes, maybe additional points, if needed, and then you graph. That's it. So technically, all the stuff that we covered in class. So say you have y equals negative 3x minus 1 squared plus, actually, minus 5. So you have a is negative 3, which is less than 0, so orientation is open down because a is negative 3. You have your vertex at 1 and negative 5, and that vertex is a maximum, right, because it opened down, so it has a max. So that's the standard form. You can FOIL to get the ax squared plus bx plus c if you want to. So that stuff is standard. Factor a polynomial like, I don't know, 3x cubed minus 5x squared plus 7x minus 1, right? Using PRS, right, where you come up with a list of possible rational zeros. That's what PRS is. Possible rational zeros, you test each of the... Now, obviously, this will not work here because I just tossed any numbers at it. But when I'm creating a problem, I say, you know, I want positive 5 to be answer. I want negative 1 to be an answer, and I want, here's the spicy term, right? So your answers are 5, negative 1, right? But what happens is, for me to create the problem, right? So this is how I create the problem. So I FOIL all of this. Welcome. I FOIL all of this, and I come up with a polynomial. You guys will do the PRS and everything else, and you will have this as the answer. So, well, I don't want to leave the bad thing up there. So what do I get here? I get x squared minus 4x minus 5 times 2x minus 3 is 2x cubed minus 8x squared minus 10x minus 3x squared plus 12x minus plus 15. So this is 2x cubed, x squared and x squared minus 11x squared, and then minus 10 plus 2x plus 15. So this would be the answer that I'm looking for. Right? You write it in a factored form where you have 3 factors. Each one of those has its own. Right? Create polynomials by, if I give you, create polynomials from roots. So I give you that the roots are 3, negative 2, and 1 plus I. So if I give you something like this, you immediately create x minus 3, x plus 2, x minus 1 minus I, and x minus 1 plus I. So you know that this is, right, it has to have a conjugate, which is x 1 minus I. Since it has 4 roots, you have to have order to the 4th. So FOIL all, and you're done. You need to be able to graph rational equation. So if you have f of x equals to 3x minus 1 divided by x squared minus 1, you need to know that vertical asymptotes are x equals plus minus 1 when you set denominator equal to 0. Horizontal asymptote y equals 0 because denominator has a higher exponent. No sa, because we have horizontal, you can't have both. X-intercept is when y equals to 0, so it's at 1/3. So x-intercept is 1/3 0. Y-intercept is when you set all of these x's to 0, so you get 0, 1. Domain, should have done that first. You have 2 breaks, right, because you have 2 vertical asymptotes, so 2 breaks in the domain. And this might be good enough for us to graph. So we place our asymptotes. So let's use this as 1 unit. So this is negative 1 and positive 1. And we also have the horizontal asymptote at 0. We have the y-intercept at 0, 1. We have x-intercept at 1/3. So 1/3 is right there. There are no other x or y intercepts anywhere. So it seems that the function, well, let's see. We know that this part of the function goes down and follows the asymptote, right? We know this. But what I'm going to do is I'm going to calculate additional points. And we're done. So we're going to calculate x equals negative 2, x equals negative 1/2, and x equals 2. Those are the points that we need to calculate because we are not sure whether it goes here or it goes there. So for x of negative 2, which is right here, that will come up with this point or that point. Whichever one is there, you draw the line through that point. So f of negative 2 is equal to, we go and look, negative 2, so it's negative 6, negative 7, so it's negative. So that's the behavior. F of 2 is positive. F of 2 is positive. That means this type of behavior, it's 2 because it's a positive value. So yeah, the asymptote is at 0, so it's either the game of positive or negative. You plug in the calculator all of your points, and you will get a number that is above or below. The only thing that is left is to check negative 1/2. So negative 1/2, that's going to give me negative 3/2 minus 1 over 1/4 minus 1. All of these are negative numbers, so that's bigger than 0. So negative 1/2 is bigger than 0. That means that this piece is going to look like that. So one more time, as I'm creating this, I put all of the asymptotes first, because those are the guides. I put all of the points that I have, and since the only x-intercept is there and the only y-intercept is there, that means that the line can't cross, function can't cross anything else. But still, you can draw a function above or below, which is the reason why I'm calculating an additional point. If I get a positive value, I have to draw above. If I get a y to be negative, all negative y's are below. So I didn't care what the value was. I just wanted to know whether it's positive or negative to draw below or to draw above if it's positive. So you see over here we got positive for f equal 2. You get a number. That number is positive or negative. So since we got the positive number, I draw above. We got a negative number for negative 2, I draw below. And I got a, over here, I know it goes to this point and goes to that point. So it has to do this. That's clear. But I'm not sure if it's going to bend down or go up. That's what I don't know, which is why I calculated negative 1/2. So calculate negative 1/2, plug everything in, and I get the negative divided by negative. That's positive. So positive goes up, this one goes down, and yeah, fun part. So technically that's the exam. You will have to use, probably there's going to be a division problem for polynomials. You are going to have a lot of synthetic division because of that problem where you have to factor everything and do stuff. One of these graphing problems, and to create a problem, and maybe separate problem for asymptotes, and one problem included here. Question on a quadratic, right, to get the vertex and orientation and maybe convert it to the other form. So everything we did in class, I would call it straightforward. So hopefully we'll be fine. There will be a SI review session as well before the class. Try to make that one as well. If you have any questions, I have office hours, and those hours are on the syllabus. See you all on Tuesday.